In the name of Allah, the most gracious, the most merciful. Welcome to the Whole Tech channel. Today our topic is Mosfet. The metal oxide semiconductor field effect transistor, Mosfet, is a type of field effect transistor, FET. The field effect transistor, FET, is a three-terminal active device that uses an electric field to control the current flow, and it has high input impedance, which is useful in many circuits. The field effect transistor, FET, is a key electronic component using within many areas of the electronic industry. How a field effect transistor works? In the FET, current flows along a semiconductor path called the channel. At one end of the channel, there is an electrode called the source. At the other end of the channel, there is an electrode called the drain. The physical diameter of the channel is fixed, but its effective electrical diameter can be varied by the application of a voltage to a control electrode called the gate. The conductivity of the FET depends at any given instant in time on the electrical diameter of the channel. A small change in gate voltage can cause a large variation in the current from the source to the drain. This is how the FET amplifies the signals. Source is the terminal through which the majority charge carriers are entered in the FET. Drain is the terminal through which the majority charge carriers exit from the FET. The gate terminal is formed by diffusion of an N-type semiconductor with a P-type semiconductor. This creates a heavily doped P-N junction region that controls the flow of the carrier from source to drain. The Mosfet is most common type of transistor today. Their primary use is to control conductivity, or how much electricity can flow between its source and drain terminal based on the amount of voltage applied to its gate terminal. Construction of basic design of Mosfet. Just take a block of P-type semiconductor. This block will be your base for Mosfet. We also call it a substrate, and the entire Mosfet we will fabricate at this base. Now two portions on same side of this P-type substrate are made highly doped with N-type impurity, as these are shown here. Drain and source terminals are brought out from these two ends. Now entire substrate is coated with silicon dioxide, which behave here for insulation. Thin metallic plate is placed. This metallic plate will act as gate contact to substrate. The gate terminal will be taken out from this metallic plate. Gate contact is insulated from the substrate, but drain and source terminal will be directly connected to respective N-type region. Source and body terminals will be connected to each other. As drain and source will connected with DC voltage source, there will be two P-N junction formed. One is between N-type drain and P-type base, and other N-type source and P-type base. As drain is connected with positive terminal of source, the drain is in higher voltage than base. This P-N junction is reverse biased. On other side, P-type base will be at high potential than N-type source. Hence, this P-N junction is forward biased. So we can say in between two terminals there will be one forward bias and one reverse bias PN junction, and there will be no current flow between drain and source, but small amount of current will flow between drain to source due to minority carriers. If we apply some suitable voltage on gate, a positive potential will create on gate contact plate, and number of electrons accumulate towards gate contact plate depends on positive potential given to gate terminal. More the applied voltage, greater the width of channel between drain and source, mean great current flow between drain and source. Here we can say that there is no direct connection between drain and source and are insulated to each other, but due to electrostatic attraction the conduction channel between drain and source is formed, due to which the channel is also called induced channel and device is called induced channel Mosfet. If you like this video, kindly share it to others, subscribe my channel for more videos, and don't forget to press the bell icon.